Welcome back. In this video, we're going to set out and follow the instructions for a strategy for solving linear equations. We'll work with this particular sample. 3 times the quantity x minus 2 all over 5 equals 3x plus 6. The first thing we want to do in our strategy is check to see if there are any fractions. And of course we have some. We have the fraction 3/5. So what we want to do is we want to multiply every term on both sides of the equation by the least common denominator. So the only denominators we have 5 on the left and 1 on the right. So our LCD is 5. So we can go ahead and multiply both sides by 5. Now this can be a little tricky, but because all we have is multiplication here, because we're going to distribute the 3, when we multiply the left side by 5, the 5 here in the denominator is going to cancel with our 5 that we're multiplying by. We don't have to worry about multiplying the 3 by 5 because we really have 3/5 here. And we don't have to worry about multiplying the x minus 2 by 5 as well, because if we distributed the 3, if we decided to multiply the x by 5 and the negative 2 by 5, well, we've already multiplied the 3 by 5, so we'd be duplicating our efforts there. But on the left side, or pardon me, on the right side, we have two terms. We have 3x and 6. And we do want to multiply both of those terms by 5. Okay, we want to multiply every term on the right side and the left side by our LCD. And we have done that now. So we're left with, on the left side, we have 3 times the quantity x minus 2 equals 15x plus 30. So now we've multiplied every term by the LCD. Step 2 says, simplify in parentheses if possible, and then distribute to remove any parentheses. So we'll go ahead and distribute the 3. So by distributing the 3, we end up with 3x minus 6 equals 15x plus 30. So we've distributed, we've done step 2 here, and that's our final result. And then we can simplify each side of the equation by combining like terms. Well, we really don't have to do that. That's all set for us. So we have 3x minus 6. 3x minus 6 equals 15x plus 30. Our next step, step 4, is to move all variable terms to one side and numbers to the other side by addition and subtraction. So because I have the larger absolute value over here on the right hand side, and I always like x to be positive, I am going to move my x's to the right side. So I'm going to subtract 3x from both sides, which means then I have to move my 30 by subtraction to the left side. So negative 6 minus 30 leaves us with negative 36 equals 12x. Step 5 says isolate the variable by multiplication or division. So we have multiplication here, so we will divide both sides by 12 to get x all by itself, and we get x equals negative 3. And then finally, we want to check our solution in the original equation. So let's go ahead and do that. We'll check that. And we get 3 times negative 3 minus 2 all over 5. Our fraction is back. Equals 3 times negative 3 plus 6. So we end up with 3 times negative 5 over 5 equals negative 9 plus 6. So we get negative 3 on the right, and sure enough, negative 5 over 5 is negative 1. We get negative 3 on the left, and that does check out. So let's take a look at a few sample problems. 5 halves x minus 1 equals 3 halves x minus 4. Well, here we do have fractions. They're back. I have two terms on the left-hand side, the 5 halves x and the minus 1 on the left hand. And on the right hand, 3 halves x and the other term minus 4. Our LCD is 2, so we multiply every term on the left side by 2. We will also multiply every term on the right side by 2. So 2 times 5 halves, the 2's simplify. We end up with 5x. And 2 times negative 1 is negative 2. On the right side, 3 halves x multiplied by 2 is 3x. And negative 4 times 2 is negative 8. Following our strategy, we want to combine all the x's on one side. So I'm going to subtract 3x and move it to the left-hand side, leaving us with 2x. And I will add 2, since I had minus 2 with plus 2, I will add 2 to both sides to get my numbers on the other side. Equals negative 6, and x equals, well, pardon me, divide both sides by 2, and x equals negative 3. I'm doing a bunch of work in my head there. The next sample problem has decimals in it, a little more challenging. Sometimes the temptation is to go ahead and multiply 2/100 times 8 or distribute the 1/10. But because we have decimals, what we can do, we can multiply every single term by 100, since we're out to the 100th place. So the 6/100 x times 100 will become 6x. And the 100 times 1/10 times x minus 2. Now here we only have to multiply by the 1/10 because once we distribute, that will be like multiplying the x and the negative 2 by 100. So we're fine here. So we get minus. That will become 10 times the quantity x minus 2. Do not multiply what's in parentheses by the 100. And then multiply the negative 2/100 by 100, and we get negative 2 times 8. So we'll simplify. We get 6x minus 10x. I'm going to distribute the negative 10 plus 20 equals negative 16. Combine my x's, I get negative 4x plus 20 equals negative 16. I will subtract 20 from both sides. Get negative 4x equals negative 36. Divide by negative 4, and x equals 9. Sample problem 3. Looks like we don't have any fractions, but we can do some distributing here. So I'll distribute the 5, and I'll distribute the 3. So we get 10 minus 5x plus 8x equals 3x minus 18. 10 plus 3x, or if you prefer 3x plus 10, using the commutative property, equals 3x minus 18. I want to solve for x, so I will subtract 3x from both sides, and something odd happens. My x's all cancel, and I get 10 equals negative 18. Well, that doesn't make sense. I don't have any x. 10 equals negative 18. How can that happen? Well, that answer is no solution. And you may have noticed here that 3x plus 10 equals 3x minus 18, that something unusual happened. What we're doing here, if you think about that, x is some number, aren't we tripling it, 3x? So we're saying let's triple a number and add 10. Well, that's the same as tripling the same number and subtracting 18. Yeah, that doesn't make any sense. So no solution for that. Problem number 4, we're going to distribute our negative 4. We get negative 4x plus 16 minus 23 equals negative 7. We'll simplify negative 4x. 16 minus 23 that's negative 7 equals negative 7. Now be careful here. Don't jump to any conclusions. Let's solve for x. We'll add 7 to both sides. We get negative 4x equals 0. Well, believe it or not, we can keep going. We can divide both sides by negative 4. And we get x equals 0 over negative 4. And, of course, 0 over negative 4 is 0. So x equals 0 is our final solution. 0 is very different than no solution. 0 is on the number line. So if we put 0 in for x, that will work. And sample problem number 5. Let's go ahead and distribute. So we get negative 12x minus 6 minus 14 equals, we'll distribute the 10, negative 10x minus 20 minus 2x. I'm going to combine or simplify here, so we'll negative 12x minus 20 is equal to negative 12x minus 20. So you may notice that this side is exactly like the right-hand side. In this problem, the right-hand side and the left-hand side were different, but here they're the same. Let's go ahead and add 12x to both sides. We get negative 20 equals negative 20. If we added 20 to both sides, we get 0 equals 0. That is a true statement, which means no matter what number we put in for x, this will always work. And we can see here we have equivalent expressions. They're exactly the same on the right and on the left. So this is, we have an infinite number of values that we can input for our x that will work. So this is infinite number of solutions. So take a good look at those three. That's somewhat of a challenge for beginning algebra students to recognize the difference between no solution, 0, and an infinite number of possibilities for x. So that wraps up our strategy for solving linear equations, and we will see you in class.